Hello everyone, I hope you all are doing well. I welcome you all to my video classes on hardened concrete. So in this we are discussing mainly about the durability of concrete. So in this we are definition of durability of concrete, significance of durability of concrete, factor influencing the durability of concrete, then internal and external causes for durability of concrete. So first we'll understand what you mean by durability of concrete. So durability of concrete may be defined as the ability of the concrete to resist the weathering action. To resist the weathering action, chemical attacks, abrasion, while maintaining the desired engineering property. So here is main important is to maintain the its desired engineering property. So desired engineering property means load carrying ability, right? Safety, durable, safety, stability. All it is what we are designing for some particular load condition, a particular requirements. So those particular requirements should be there in that structure, but it has to resist the weathering action or decaying. You can see the image in this because of some decaying or weathering conditions, or because of the some changes, the plastering layer or concrete layer is collapsing. Why? Because it has a less durability and it is not resisting properly. It's not resisting properly. So that's what here durability of the concrete may be defined as ability. Ability means strength for concrete to resist the weathering action, chemical attacks. So chemical attacks means what? It may be a acid, or it may be in the form of gas, or in the form of some rain, acidic rain, and abrasion, removing or wearing, tearing, right? It has to maintain and with a particular engineering property. So a durable concrete should maintain its original form. So original form and serviceability when exposed to adverse environment. So it is what requirement of or a purpose of durability. So durability tells us a concrete should maintain original condition, original size and shape, and serviceability. It has to give service when exposed to adverse environment, right? So you can see in the image I told, right? It is not maintaining the original form, right? So it is even you can see the corrosion of the bars and silica reaction, right? So you can see that it is because of non-good durability. So now we'll see next significance. So why durability is taking more importance? So why we have to give more importance for durability? So we have to take considerations of durability. So we will see one by one with a point, right? So first point is much money is spent on repair work and maintenance of concrete structures. So first point is what we are spending more investment, or we are spending more money on repair works. So why repair works? Because not in a good condition. So that's what you can reduce that 40% of investment of the total structure cost, that you can reduce by proper durability or maintaining the proper durability, right? So main intention is reduce the cost requirement, and same cost you can invest in other place, right? So next, present age all good and favorable site of construction have been already used. So here they are telling that present age of all good and favorable sites. So before constructing any structure we'll see the site, right? So in that all good and favorable sites for construction are already used. So now we are going for some constructions where exactly site is not in a good condition, right? So even we are going with some challenges. So because all the good sites are plain or something whichever ideal for construction, these are now already constructed. So that's what we have to take care of durability with the new techniques and new methods. So next, all good concrete materials, cement, sand, aggregates, right? Some other requirements are in short supply, means we are not getting how much we required for the construction. So example, you can take river sand. So many of the places we are not getting the river sand. Why? Because it is in a shortage, right? So that's what we are compromising with some requirement. So when you are compromising with, we have to maintain the durability. So that's what. So now a challenge is to maintain the durability. And Thus, the construction of modern concrete structures assume much more importance for durability than the past. So earlier we used to get all the materials and all three conditions are favorable, but now we are getting problem, right? So that's what nowadays we have to take more about the durability of the concrete. So due to these reasons, in a revised IS 456/2000, the approximate value for cement content, maximum water treatment ratio, minimum grade of concrete has been suggested for different exposure condition. See what exactly they want to tell. Like no, due to the changes and due to the conditions in addition of IS 456/2000 code book in India, they had made changes for the some conditions for cement content, water cement ratio, minimum grade of concrete is a code book. So in the code book they will tell what are the minimum condition we have to maintain for the good structure. So even you can see in the table, in this table you can see serial numbers 1, 2, 3, 4, 5, exposure, mild, moderate, severe, very severe and extreme. See, a structure will be there, it is exposed to environment. So here in the environment, what are the different exposures? So these are included and it is updated because of the some hazard environmental conditions. Even you can see in this plain concrete, right, reinforced concrete. So they given for plain concrete separately and even they are giving for reinforced concrete with bar and without bar. So here also you can see minimum cement content, so right, for plain concrete minimum cement content, so then maximum free water cement ratio, minimum grade of concrete. So similarly they are given for reinforced concrete. So why? Because change in the environmental conditions and updations. Next, so factors affecting the durability. So what are the different factors which are controlling the durability of the concrete? So many factors are there, but we'll discuss one by one some of the general and main factors which are influencing the concrete as an overview. So first one is cement content. So in the cement content, right, actually it is one of the requirement of concrete. So here also if you use a less concrete, if you use less cement in the concrete preparation, then workability reduces. We know workability means it should be concrete, it should be in such a way that it has to place properly. It has to like no good condition. Workability means what? The concrete is very good, right? But if you use a less, workability reduces. Workability reduces, but if you use more, then drying shrinkages causes, like no creation of drying shrinkage. We know what you mean by shrinkage, right? But here if you use a excess amount, then it causes the drying shrinkage. So that's what we have to use. Optimum condition means we exactly how much is required by proper design and calculation we have to use with the optimum condition, should not be less and should not be more. So next we'll go for next factor, aggregate quality. So even aggregate is one of the like no material which is required for preparation, but here we are mainly dealing with quality. Aggregates are there, but we have to go through the quality, right? So one is well graded is required, right? Proper how much is 10 mm, 15 mm, like no mm, so we have some different mms, right? So some concrete required lesser and some concrete require bigger size. That's what well graded, right? Less moisture content should be less, and shape of the aggregate is very important. Here if you want to get a good durability, then rough structure angular aggregates are good. Rough structures angular aggregates are good for to get a good durability. So here well graded is required, less moisture content is required, shape of the aggregates takes the main role for the durability. So for the good durability and rough structures angular shape aggregates are good. Next we'll see water quality. So water quality, here also we are taking the quality. So we have different biological characteristics of quality, like no biological quality of water, physical quality of water, chemical quality of water. For example, physical color of the water. So even color is a main factor. For example, water do not have any color, but due to some reactions, due to some pollutions, we are getting gray color, muddy color. So that's what water quality is also important. But specifically if we have to use potable water, means drinkable water, which we are using for drinking water. Similarly same water we have to use for
construction, right? Preparation of concrete. So here they are mentioning mainly about the pH. If pH of water is 6 to 8, then it is good. If it is not in the range of 6 to 8, then it causes the problem. And water should, if causes the problem of corrosion, so that's what it has a pH of 6 to 8. We know what you mean by pH. It is one of the parameter of water quality parameters. Then it should be free from oils. See, we have some like no pollutions. If you go for some of the rivers, due to some discharging of waste from some industries, they are getting oil content in that water, acid contents, alkalinis, salt content, and sugar content. For example, sugarcane industries are supplying like discharging the water to the rivers, right? So those content, if it is there in water, then it affects on the concrete and it reduces the durability of concrete, right? So even water quality is very important, and here they are mentioning potable water is good, and if it is non-potable, then reduces the durability, right? It affects on the durability. Next we have concrete compaction. So these are the points, even you can, these are the main points, it will take in all the parameters. That's what concrete compaction. Compaction means what? Removing the air from the concrete. If you air is there, then it creates the, it reduces the durability. So improper compaction, more air voids. So if you have more air voids, then it causes the durability. It may causes the cracking, or it may causes the creaks and shrinkages. So that's what properly compacted, right, and less air voids, right, it impacts on the durability. So what exactly we required? Proper compaction is required, less air voids, and then we will get a good durability. Otherwise reduces the durability. Next, curing period. So here curing, we know what you mean by curing. It is applying of water on the surface of concrete, but here some time is required. For example, we have a 24 days of curing, 28 days of curing, 7 days of curing, 1 day of curing, right? So proper curing has to be made to avoid the shrinkage cracks. So then durability. So if you are not making the proper curing, improper curing, then it causes the shrinkage cracks. Then if it's a shrinkage cracks, definitely it reduces the durability, right? Proper curing is required and sufficient time is required. So next is permeability. So we know what you mean by permeability, right? So penetrability of water. If water is more penetrating in the concrete structure, definitely it expands its volume. When it expands its volume, deformation will take place. So due to the deformation, cracks will take. So due to the cracks, durability decreases. When water penetrating to the concrete, so then definitely there will be change in the volume. So when volume is changing, definitely will get a cracks. So when you get a cracks, then definitely durability decreases, right? So next we have moisture condition. So moisture condition in the atmosphere. So for example, a structure is constructed to the environment. So when the moisture content in the atmosphere, for example in humid, so for example morning, so morning water content in the atmosphere is more. If you go for afternoon, water content in the atmosphere is less. So you know, even in evening it will have some moisture conditions. So if you have more moisture condition in an atmosphere, then efflorescence will take. Efflorescence means some kind of white patches. So you've seen in many places, for example mainly in rainy seasons, if you see any wood, you will get the white patches. Similarly on the concrete also we are getting some white color patches. It is efflorescence, right? So that reduces the durability of concrete. That reduces durability of concrete. So next is temperature. So higher the temperature, right, spalling and deterioration will takes place. Why? Because higher heat of hydration. When you have higher heat of hydration, definitely deterioration means what? Cracks and we are getting falling of some plastering materials or cover materials, deteriorating of the particle of cement aggregates. They are deteriorating means they are separating. So because of higher temperature causes the rapid heat of hydration, then rapid heat of hydration causes the cracks. So right, that causes the effects on the durability of concrete, and higher the temperature, less will be the durability. Next, continuation part of factors affecting the durability. Next is abrasion. Abrasion means what? Wear and tears. So where you will get a wear and tears? Where you have a more wind blow, right? So where you have a more wind blow, but exactly these kind of effects in a streams. For example, when you are constructing channels, maybe like no drainage, for example, gutters and channels for streams, right? Due to the silt and like no some stone particles in the water, it may wear or tears the bed of the channel. So due to the wear and tear of the bed of the channel, it causes the corrosion to the reinforcement, and it makes the deterioration of concrete. So that's what, more is the abrasion, less will be the durability. So it has a direct impact. We have to reduce the abrasion or wearing of surface of concrete. So mainly due to the high velocity of water in some places, even in some places because of high wind blow. So next is carbonation. Carbonation. So carbonation means what? We have in environment CO2, carbon dioxide in the environment, right? So when carbon dioxide is there in the environment, it will react with the cement particles. It will react with the moisture concrete. When concrete in a moisture condition, it will react with the carbon dioxide. So then pH reduces. When we have an interaction between atmospheric carbon dioxide and moistured concrete, so it reduces the pH. So when his pH is reducing, it causes the corrosion of the bars. So when corrosion of the bars are taking place, then strength reduces the for example, why we are using the bars to handle the tensile forces or tensile resistance. So when is not good in a tensile resistance, definitely it makes the cracks formation. When you have a cracks formation in the concrete, then definitely durability reduces, right? So next we'll go for wetting and drying cycle. So it is what cycle between wet condition or moisture condition and drying condition, means becoming drying. So where you will get these kind of actions frequently or frequently in the coastal areas or in the boundary of sea. So in the boundary, for example, when you are constructing the sea barriers, so you are constructing with the help of concrete structure, and it will get the repetitive cycle of wetting and drying conditions, right? So due to this, it has some action or chemical actions because of some chemical contents in the seawater. For example, you can see sulfate attack. So that is also one point, but it is forms mainly because of a wetting and drying condition. Sometime it will get a wet condition, sometime it will get a dry condition. So due to alternative condition, right, due to mainly tidal wave of sea and some other conditions, it reduces the durability. Next is freezing and thawing. So right, so freezing means less temperature. So due to this action, cracks will take place in the surface of concrete. So due to freezing and thawing, it causes the cracking on the concrete surface, and when you have a cracking on the surface, definitely durability reduces. Next we have alkali aggregate reaction. So here is alkali. So alkali particles will get in a cement, and silica content will be there in a aggregate. So when alkali of the cement and silica of the aggregate reacts, it creates some components. So due to these components, right, durability reduces. Why? Because it causes some deformation or change in the structure because of that reaction. So we have to avoid the more alkali silica reactions, right? So it creates the cracks, and due to cracks the durability reduces. Next we have sulfate attack. So we have seen many sulfates, right? Sodium sulfate, magnesium sulfate, right? Sodium sulfate, magnesium sulfate, right? So different sulfates are there, right? So if chemical reaction between hydrated cement paste or hydrated cement product, right? So we have a hydration, right? Due to the hydration we'll get some product, and it is a reaction between hydrated cement paste and sulfate. So due to this reaction, right, it causes some changes. So due to these reactions, it causes some problem, and it reduces the durability. Mainly it reduces the durability because it makes the deterioration of the concrete. So next we have organic acids. Organic acids. When concrete surface is subjected to organic acids like acetic acid, lactic acid, right? So different acids. So durability gets affected severely. So because of the attack side, because of the organic acids, it affects on the durability. Even gases, so because of industrialization we have some different gases, and because of more exposure towards the different gases on the environment, it affects on the durability of the concrete, right? So next we'll see internal and external factors influencing the durability. Internal means within the concrete, then external factors outside the concrete, right, which are causing the durability. So one is extreme weather condition. So weather condition is not good. For example, more rain condition. So when we have a more rain condition, even it will affect, right, in terms of moisture condition. When moisture is more, then it make the changes in the volume, right? When we have a deformation, then definitely it affects on the durability. Next we have a temperature. So extreme weather condition, temperature all belongs to external causes. We have studied in generally, but now we are classifying in terms of internal and external. Internal means what? Within the structure. External means outside the structure. So next is extreme temperature. I told higher the temperature, higher the heat of hydration. So when you have higher heat of hydration, definitely it makes the cracks on the structure. When we have a cracks on the structure, maybe it is what? Plastic cracks or drying cracks. We have studied in creeps. So we have studied plastic creeps and drying creeps, right? So next is extreme humidity. So even humidity is very important. We already studied how humidity is affecting on strength of the concrete, how humidity is affecting on the creeps, right? So what you mean by humidity? When you have a medium, moderate humidity or constant humidity, strength will be more. If you have a less humidity, then it causes some plastic shrinkage. So due to the plastic shrinkage, definitely it reduces the durability. So then abrasion. So we already studied what you mean by abrasion, right? Abrasion means what? Wear and tear. So why wear and tear will take place? Because of high wind blow with the particles, and mainly it will take place in the water channels or water structures, right? Because of the stone particles in the water or silt material in the water, and it is what? Removing of bed of the surface. Next, electrolytic actions. Electrolytic actions means some of the ionic exchanges. So we know what we mean by electrolytes, right? It is what? Ionic changes. Positive ion, negative ion, it mainly corrosion, right? So it will take some electrolytic actions, and due to these actions, definitely durability affected. Then attack by natural or industrial liquid or gases. As I told, even gases are very dangerous, acids, right? So where they are coming from? The industries. So from the industries, due to liquids and gaseous, so even durability reduces. Next, internal causes. We studied external causes, right, outside the structure. So now within the structure, what are the different factors? So many factors are there. Some are the general categorization, right? So but mainly we have to explain this. What are the internal factors within the structure, within the concrete structure? First one is physical. So how physically it is affected? So that one is volume change due to difference in the thermal property of aggregate and cement paste. So we have aggregate. Why? Because it's one of the basic need. So then we have a cement paste. So when you have a difference between thermal difference means temperature difference, right, between cement paste and aggregate, so then it may causes the change in the volume. So when you have a change in the volume, definitely it makes the deformation. So due to the deformation, cracks will take place, right? Due to the cracks, maybe structure fails and durability reduces. Next is forced action. It is what? Creation of ice particle or creation of some moisture or snow creation within the structure. Why? Because lesser temperature or less less temperature. So even most creates the expansion. For example, we know what we mean by expansion and contraction. So due to the forced creation, expansion will take place of the water. So due to the expansion, it is also change in the volume. So due to the change in the volume, it causes the cracks. So next we have chemical causes. So chemical causes means reactions. I told alkyl aggregate reaction. Alkyl aggregate reaction means what? Alkaline of the cement, then silica of the aggregate. So A, alkaline of the cement and silica of the aggregate. So due to this reaction, it affects on the durability. Some of the examples are alkaline silica reaction. So alkaline means from where? It is from the cement. So silica from the aggregate. So next alkaline silicate reaction. alkali carbonate reactions. Next, corrosion of the steel. It is also one of the process, and due to this we are getting the less load carrying capacity or less tension capacity of the structure. So corrosion it is what some of the chemical reactions between environmental moisture and reinforcement within the concrete. So these are the some examples or some parameters of internal causes for the durability, right? So right, I thank you for watching this video.